Q&A number 11, combining simultaneous equations with exponentials and logarithms. Press pause on this question, this big nasty question. See if you can do it by yourself, or if you get scared, press unpause and we'll go through the solution. So when we look at this problem, there's some strange wording here that we might not have seen before. Our solutions to the system of equations. That's just referring to the simultaneous equations, those two equations that you need to solve. And for some reason, instead of just saying solve the thing, it says, hey, your solution to the simultaneous equation, once you get those two values, I want you to do 10 times the x value times the y value. Okay, so don't be afraid of it. It's just one little extra step after you solve everything simultaneously. So we've got two really common methods to solve simultaneously. So taking you back to sort of year 10 maths, if I had these two equations using the elimination method, I would have a go at adding the two equations together and get 5x, eliminate the y's, equals 70, and be able to solve for x from there. When I look at these two equations, I can't see anything where I can add or subtract through the columns to the power x and log. I'm not going to be able to add them together and eliminate anything, so I'm probably eliminating the elimination method for now. So I'm thinking back to my other method of solving equations simultaneously, probably substitution method. I've got these two equations. I'm going to rearrange one of them to get just one variable by itself. Okay, and then I'm going to substitute this expression into here. Okay, and I'm left with just one equation in terms of x. Okay, so this is probably the method that we're going to have to use here, and we're going to look at these two equations and think, hey, how am I possibly going to rearrange one of these equations to get either x or y by itself? I'll look at this first equation. I don't think I could really rearrange anything there. Things would probably get pretty nasty, but in the second equation, I notice there's a subtraction of logs with the same base. I know I can do something there that might not end up super complicated, so that's probably where I'm going to start. So I know that if I'm subtracting logarithms with the same base, I can divide the two numbers. So x minus 2 divided by y, and then I can convert this to an index statement. You can do this using the conversion rule on your formula sheet, and then that looks like something I can probably rearrange for either x or y. Looking back up at equation 1, where it's going to go into, I'm probably going to rearrange this for x, just because I want to put it in there and not have to worry about the negative sign in equation 1. Okay, so I'll rearrange. I get 2y equals x minus 2, x equals 2y plus 2. So we can see the substitution. We can see where it's gone in green in equation 1. And now I've got an equation to solve in terms of y. It looks pretty nasty. This is going to be one of those equations where it's a exponential equation combined with a quadratic equation. So I don't like how I've got different bases here, base 2 and base 4. So I'm going to change this second one into 2 squared to the power minus y. Everything else will stay the same. Okay, and this will help me solve the quadratic exponential equation. So zooming in to focus on this task, I need to use the reverse of my index laws to get rid of that plus 2. So it's really multiplied by 2 to the power 2. See, if I add these powers, I get 2y plus 2. So I'm just going to split them up. And then minus 2 times 2 to the power negative 2y. Okay, so I'm doing a lot of work here. 2 squared is 4. And I'm just going to put the negative power on the denominator, just so I can think about how I'm going to solve this equation. So I don't like that negative 2y power, and I definitely don't like it how it was on the bottom. So I'm going to go through, I'm going to multiply both sides of the equations by 2 to the power 2y. Because I don't want that denominator. There's enough going on as it is. So I'll end up with 4 times 2 to the power 2y times 2 to the power 2y. So that's the extra one. In the middle, it'll cancel that denominator. And on the right hand side, I'll just multiply by 2 to the power 2y. So there it is with some better colours. So I really have 4 times 2 to the power 2y squared minus 2 equals 7 times 2 to the power 2y. Most of the time when you guys solve these sorts of equations, you try to make it a bit simpler doing a substitution. So I'm going to let m equals 2 to the power 2y, and I'm just going to substitute it in so it looks like a quadratic. So 4m squared minus 2 equals 7m. Okay, so from here we're just solving that quadratic. Remember, set one side equal to 0, factorize, and then use null factor law. So I've solved my quadratic, and then I remember, hey, I'm not after values of m, I'm after values of y. I can put my substitution back in. So 2 to the power 2y equals negative a quarter, or 2 to the power 2y equals 2. Okay, so I get two streams. This stream is no solution. Okay, we can never get a negative power just by raising a negative number by raising a positive number to a power. Okay, if you want to try it, you can have a go at using a calculator to figure out what this is. This will give you an error because there's no solution. On the other side, should be all good. 2 is really 2 to the power 1, so equate indices. Left with 2y equals 1 or y equals a half. Okay, so there is our value for y. So zooming back out onto the big problem. So my job is now to sub y equals a half into equation 2, okay, to try and solve for x. There we go, there's the substitution, and if you got this far, you can probably solve for x by yourself. There we are, so x equals 3, and then to go back to answer the original question, I know that alpha is 3, beta is a half. I know that 10 alpha beta will be 10 times 3 times a half, which is 15. Okay, put another so in there. That was all done non-calculator. If you're wondering where this -1 came from, it's knowing that a half is 2 to the power minus 1. So then log base 2 of 2 to the power minus 1 is -1 with a negative in front. Okay, so that's a big problem. Combines lots of skills. The more exposure you have to these sorts of problems, the better you'll do on complex unfamiliar questions, especially in the external exam. Alright, so good luck. Sorry it's a bit late, but better late than never.